On this week's episode of Science and Star Wars,
Just flying around everywhere.
space travel. Hello, and welcome to Science and Star Wars, where we explore how close real-world science has come to our favorite Star Wars technology. I'm Anthony Carboni, and joining me as always is my good buddy on the wall.
Hello, my name is Watson.
We go way back. Today, we're talking about one of the most important parts of Star Wars, actually being able to visit the stars. That's right, spaceships, starfighters, space stations. You can't have Star Wars without them. But will we ever live in space, let alone visit stars millions of light years away? The answer is, hopefully. Some private organizations are working on making space travel a reality for everyone, not just highly trained astronauts. And we already have a space station, and people do live on it. I mean, I'd live there if someone asked. Nobody's asked. It'd be nice to be asked. We're still just scratching the surface of recent developments in space travel. IBM is working on something called quantum computing, which could be vital in solving optimization problems in space travel.
Quantum computing really changes the game for problems like optimization. For example, route finding and looking for the shortest path between two locations.
You've never heard of the Millennium Falcon? It's a ship that made the Kessel run in less than 12 parsecs.
For him to have done that, my guess is that Han Solo probably had access to a quantum computer.
How long before you can make the jump to light speed?
Take a few moments to get the coordinates from the Navi computer.
And the engineers at NASA's Jet Propulsion Laboratory are creating an ion engine, which could be the next step to traveling beyond our planet.
Spacecraft are very maneuverable using ion engines. They don't move as fast, but you're able to use them very efficiently instead. We're actually able to go around the solar system and visit multiple destinations, unlike most missions where they can only do flybys if they want to go to multiple targets. With this, we're able to use less fuel to do more.
Then the next step is plasma, and that would amp things up big time. Like the Vasimir plasma engine, which could theoretically propel ships 10 times as fast as chemical engines do now.
A plasma rocket is better than a chemical rocket, a conventional rocket, because the exhaust is a lot hotter. The hotter you make the exhaust, the faster the rocket can move, and the less fuel that it consumes. So the exhaust of the plasma rocket, of the Vasimir engine, is like 3.5 million degrees, like the sun.
While there is clearly a lot of work to do, you have to be excited for what the future holds. I know I am, and I know someone who has firsthand experience, and I am so jealous. We are joined today by former astronaut Cady Coleman, a person who knows firsthand the challenging awesomeness of floating 249 miles above the Earth.
It is great to be here, though.
Oh, it is so wonderful to have you here. I have to know, you spent a stint of 157 days living in space. What was that like?
I loved every minute of it. I was not ready to come home on that day 159. The lack of gravity up there really gives us a window into the way science works. We're learning how to recycle air, recycle water, grow plants in a place where it's hard to do that. One of my favorite things that we did was the spheres experiment. These are well, you should know, because it comes from Star Wars. One of the professors at MIT, David Miller, saw that and said, I want 6 of those, and I want them on the space station. And they are helping us understand how do we get to Mars.
So you're basically using them to run simulations of how our future spaceships and space stations will work.
Exactly.
So what's happening on the space station right now?
I think the best way to show you that is to bring you to
space! I'm going to space with Cady Coleman!
Not exactly, but my friend Jack Fisher is up there right now, and he said he would give us a little tour. Jack?
Hi, Anthony and Katie. Welcome to the space station.
Hi, Jack!
I would love to show you around, but since it's such a big place and we don't have that much time, I'll just show you the US section of the space station. Come on this way. This is Node 3.
This is crazy. Just flying around everywhere.
This is our treadmill, which just so happens is mounted on the wall. We have these handy-dandy harnesses that can strap us into it and simulate gravity so that we get the benefit that we need for our bones and muscles that have to have resistance in order to continue to grow so we don't lose bone mass and muscle mass that earlier astronauts had such a problem with. Come check this out. This, my friends, is the cupola. 7 windows of viewing and photo-taking nirvana.
I miss that. It's a special place to be. When you look out at the horizon, do you see that? You realize you're in a spaceship orbiting the Earth.
That's unbelievable.
I told you it never stops.
This is the U.S. laboratory. We have all sorts of things. This place is full of systems to provide the resources for the experiments or the experiments themselves, because we're doing science 24 hours a day, 7 days a week on the inside and the outside.
So out of all the research up here, what is it that you feel the best about in terms of making a difference for people on Earth?
One of my favorite things that we're doing in here right now is called ADC, and it's immune activating antibody, but I call it a cancer-seeking missile. It goes after cancer cells that we actually have grown on the station and targets them. That'll increase effectiveness of chemotherapy and reduce the side effects that affect so many people, including my daughter, that suffer from this terrible disease.
That is fascinating.
Well, Cady and Anthony, I hope you enjoyed the tour aboard the wonderful place we get to call home, the International Space Station. But I got a lot of work to do, so I'm gonna get back to the science. See you next time.
Thank you, Jack.
Thanks, Jack. That's so amazing.
I love talking space.
I love talking to space too. And I just found that out today, thanks to you, Cady Coleman.